everyone. Welcome to OT 245, Intro to Research Methodology. Today's topic is about evaluating research quality. My name is Melissa Kay. And here are your objectives. Just two today. The first is to explain, let's get that back in there. Explain terms used to describe quantitative and qualitative research, and then to describe the measures of quality in quantitative and qualitative research. So we've gone over quant and qual, and now we're getting into, okay, how good is it? So there's some characteristics of sound or quality research. It explains the accepted rules and procedures for the type of research. It describes approaches used in the investigation. And, when you're thinking about this, you could think about a journal article, right, where they have their methods section. And so they're describing what they're doing very clearly. They're adhering to the chosen methods. And, you're getting this information through a journal article, but it's going to be in the protocols for the study. And then others are informed about the procedures, problems, and limitations of rigor. So people are upfront about how it went. We use very different types of measures for determining rigor between quantitative and qualitative. So you see on the left, the design quality, the instrument quality, procedural quality, and adequacy of the sample are the quantitative measures. And for qualitative, data quality, procedures quality, and reflexivity and analysis. So remember that reflexivity is your ability to look at bias and look at who you are as the researcher and self-examine during the process of being a researcher in a qualitative study. So similar, but a little bit of difference. We're going to dip in just a little bit to the quality of the instrument, right? So we want a recent publication date, or for some instruments, they've been around for 1 million years. They're really great. They don't need to be like reinvented, but we want the norms to be updated on them. We want to know that the instrument, otherwise known as the tool or the test, right, to have been cited by other researchers, that there's reviews available so we can see what it's like and how rigorous it is, that the structure fits our research questions and or hypotheses, that it uses accepted scales of measurement. So we want to be able to understand the scale of measurement and also convey that in our findings easily. And that reliability and validity information is available. And often it's available in a guide or a manual that comes with the test. So let's look at terminology. Oh, and throughout this, if you want to go back to one of the sections, the big sections are marked by this big pink bar on the bottom. And then the different terms have this style of slide with the green border. So you can easily go back and look at a particular section. Also, as always, broken record, check out the presenter notes. All right, so measurement. Translating observations into numerical values that represent an underlying empirical concept. So what is empirical, first of all? It's based on or concerned with being able to verify an observation or experience rather than just using pure theory. So we actually makes it concrete, right? When we measure our observations, it is the analysis part after we've collected the data or during collection of the data, right? And so this measurement lets us know how certain we are about what we found. This is kind of it's a little bit of a review, and it's also a nice type of looking at measurement of different types of data, because you can do different manipulations with different types of data. So on the left, we have categorical data, which, if you'll remember, is composed of nominal and ordinal. And there are definitions here on the slide deck for you. And then numerical data is interval and ratio. And you want to note that categorical data cannot be mathematically manipulated. For example, it can't be added, subtracted, multiplied, or divided. It can only be described. So when we're thinking about measuring and doing some like super serious number crunching from data that we've gathered from an experiment, we want to use interval or ratio. A chart that just tells you what you can do with different types of data, right? So you can, with nominal data, you can count it, and that's about all. With ordinal data, you can find out a median or a percentile, and you can count it, and that's all, etc. So go back to this as you start learning about various studies and digging into them for your lit reviews to think to yourself, okay, how much manipulation could they do, and how does that affect their outcomes? So interval data, there's equal spacing between measures, right? And examples are speed of fine motor. So these equal spacings are seconds or fractions of a second. Some examples are the 9-hole peg test and the Purdue pegboard test. Both of them ask a person to move pegs from one place to another, little teeny pegs, and we can measure how fast they did it. And it translates into how speedy is your fine motor, right? It could be impacted by an intention tremor or a resting tremor. It could be impacted by having an injury to your hand or arm. So we're measuring an interval, and the instrument does not need to start with a 0 point. So it's not important that that you go down to no data whatsoever, right? So if we're measuring speed of fine motor performance, chances are there's something that person can do, even if it takes a lot of seconds. Ratio data, in contrast, the scale begins with an absolute 0. And the example is a grip strength test or a time test. Now, I just said, how many seconds does it take to do the pegboard test, right? And that was our interval data. This is time or strength. Your strength could be 0, right? You could have a flaccid upper extremity and you have 0 strength. There is an absolute 0. You cannot squeeze the grip strength meter at all. With time test, you could not be able to stand on one leg at all. So there's a 0 point. So it's a little bit of nuance, but try to keep these separate in your mind, interval and ratio, and know that they're the two types of data that you can manipulate the most. Moving on to our next term, reliability. This refers to the consistency of a research study or measurement test. So for example, if a person weighs themselves during the course of the day multiple times, they could expect that they would get similar readings. Maybe not exactly the same, but similar. Scales that measured weight differently each time would be really not very useful, right? If findings from research are replicated consistently, then they're considered reliable. This is really important because we want our results to be reliable. Like if somebody else did the test, if we did the test over again, we would get similar results. A correlation coefficient can be used to assess the degree of reliability. And a test is reliable if it shows a high positive correlation. Now, you may recall from your statistics course that a perfect correlation is 1.0, right, or 100%. And so we're backing down from this 100% or 1 into fractions, decimal places actually. All right. So reliability can be reflected by this relationship. O, which is the observed score a person gets, equals their true score, which is what they can actually do, plus their error score. So it's expressed as a correlation coefficient, as I just said. R, which is the correlation coefficient, is 0.80, and 0.80 or higher is generally acceptable. So when we have this reliability relationship, the true score plus the error score is what we wind up with, because there's always the chance that there's an error, that some other factor that we didn't account for came into the testing, right? So we use this equation and it includes a margin of error. Different types of reliability: test, retest. That means if I give the test today and then I give it a couple weeks from now with no intervention, that person should score pretty much the same. And obviously, if I give it a long time from now, they may not score the same because of a variety of reasons. If I give it too close together, they might score better because they've learned the test a little bit. So test retest is with a margin of time in between the different trials of the test. Internal consistency means that within the test, you could do the things in a different order, and they would the items in a different order, and they would come out with the same result. So one way to do this is something called split half consistency. So if I have two groups and I have 20 items, I give all the odd items to group A first and then the even ones. And for group B, I give all the evens and then the odds, right? So I kind of mix up what's happening, but I keep the same items in the test, and I should get the same results. The order of items should not influence the reliability. And then equivalence is the third type, and it's agreement between two measurement events. Inter-rater is one type. So if I give the test and my friend gives the test, we should to the same person. And so, this has to be hypothetical, right? Because if we both give it to the same person, then they've learned about it, right? Then we get into test retest a little bit. But if we give the same test hypothetically to the same person, or if we do it in a short order of time, we should get likely the same results. So this also brings into question our scoring ability, and are the scoring instructions accurate, and are our observations accurate, and do we understand what the test is asking? One example of this is a test called the EASY, the evaluation of air sensory integration. And I worked on the inter-rater reliability of it. And so we had a team of student researchers, and we all gave the test. And we looked at videotapes, right? So videotapes of a child performing the various items on the test. We all looked at it, and then we all rated it separately, and then looked at and discussed any differences in our rating. And the idea was that we were working on the inter-rater reliability of this new test. The other way that we could have equivalence is alternate forms, if it's a pen and paper test. So there may be a set of questions A and set of questions B. If we're going to use both those sets, we should come up with similar results. Threats to reliability. So there's a lot in the presenter notes about this. I'm going to go over it a little bit high level. So threats to reliability are factors that cause or are the source of error. Now remember, our true value plus our error value equals our observed value. So researchers can have error, and I just described that with the EASY, right? So errors in scoring or observation or interpretation of what we saw. Environmental changes can cause error? What if the fluorescent lights started blinking? What if the room got really cold? What if it was a different time of day, etc.? Changes in participants cause error. And then there's random error, which is just like stuff in the world that can affect the reliability of a test. All right, it's time to take a break. Go away, stretch. And I guess I'm getting in the habit of stretching when I say stretch. Get a drink of water, come back, and we'll go through the second half. I'll see you in a minute. All right, welcome back. Next up, validity. The validity is the extent to which a concept is accurately measured in a quantitative research study. So validity is, for example, a survey that's designed to explore depression, but it actually measures anxiety. That would be considered not valid, right? So how accurately are we measuring the concept? And is what's being measured a true reflection of the underlying concept? So if we take the concept of something like, for example, earlier in the semester, I talked to you all about my resilience study, right? So when we measure resilience, we can't measure it directly. There is no thing that we can use to measure resilience because it's this concept or construct. So what we can measure is protective factors, which are the things that help somebody cope with adverse events. And then we can use that and apply it back to, okay, is this a measure of resilience? So we want to be really sure with some of these things that are hard to measure, like satisfaction, motivation, resilience, depression. We want to be sure that the questions or the activities or the instruments that we're using actually measure what we want to measure. It sounds logical and obvious, and when you get into it, it can often be very challenging. We have two types of validity, internal and external. Internal validity is the degree of confidence that we have that the causal relationship that's being tested is trustworthy and not influenced by other factors or variables. So the internal validity is how sure are we that what we're measuring is really trustworthy. External validity is the extent to which the results from the study can be generalized to other situations, groups, or events. So that's taking it out to the population. Now, sounds great, but in reality, we need to balance internal and external validity. So greater internal validity can lead to a lesser external validity and vice versa. If we're in a lab setting, we have greater internal validity, right? So we've kind of controlled for all of the cuckoo things that could happen that we don't want to influence the behavior of our participants, but we lose the actual real world setting of of where they live and where they work and where they actually are doing these behaviors. If we take them out into the real world, then we run the risk of having confounding variables come in. So in any study, it's going to be important that that we balance the internal and external validity. This is a chart that Dr. Chang made that just looks at internal and external validity and when they come into play. So you can have a look at that if you'd like, and if you're a visual person, it can be handy. And then there's different types of validity. So the first is construct. It evaluates whether a measurement tool really represents the thing we're measuring. And it's what I talked about to start with, right? A construct is a concept or characteristic that cannot be directly observed, but it can be measured by observing other indicators that are associated with it. So, in addition to the things that I noted, characteristics such as intelligence, job satisfaction, or depression, gender equality, freedom of speech, all of these things are hard to measure and quantify. Content validity is up next. And content validity assesses whether a test is representative of all aspects of the construct. So does the test really cover all of the various facets of a construct or a concept? So an example is a math teacher develops an end-of-semester algebra test for her class. The test should cover every form of algebra that was covered in class. If some types are left out, then the results may not be an accurate indication of the student's understanding of the subject. Similarly, if she includes questions that are not related to algebra or questions that they don't know the answers to yet because they haven't learned those concepts, the results are no longer a valid measure of algebra knowledge. Face validity is next, and it is how suitable the content of a test seems to be on the surface or on the face of it. It is similar to content validity, but face validity is a more informal and subjective assessment. So know that the two go together, right? So content and face go together, but content, we dig much deeper. Face is like, yeah, looks good, or, no. And then finally, criterion validity. So this evaluates how closely the results of the test that you're administering correspond to the results of another test that measures the same thing. So in OT, an example of that is we have a couple different types of tests that measure gross and fine motor skill, right? So if we use test A and test B to measure motor skill in preschoolers, we want to come up with very similar results, right? So we want the results of our test to be very similar to something else that has already been verified as being reliable and being valid. I'm not going to confuse you. Okay, so that is, those are the four different types. Threats. There are a whole bunch of threats to internal validity. And I'm going to have you have a look at them in the presenter notes and also in your readings. Please bring your questions to class. Threats to external validity. There's two, reactivity and realism. So reactivity is the extent to which participants are responding to being part of a study. So they're reacting to like being in a study as opposed to being in real life, right? And they act differently because of that. They may be nervous, they may be trying to show off, they may be reluctant, they may be a whole bunch of things, positive or negative, but it changes their behavior. And then realism is the extent to which the experimental conditions actually simulate real-life situations to which the population is exposed. So again, there's that balance of doing something in the lab so we have a lot of control, or doing it in the real world so it simulates how things actually are, right? And realism is the extent to which how we tested a group of people, a sample of people, actually simulates real life. All right, so now we're on to our second big topic, which is qualitative research terminology and rigor. So we use the term trustworthiness. In qualitative research, trustworthiness is about establishing credibility, transferability, dependability, and confirmability. So those are the four terms that you need to know along with trustworthiness. And they apply again to qualitative research. Credibility answers the question, has the researcher represented multiple realities revealed by informants as adequately as possible? So are the results credible? Are they believable? Transferability is the degree to which the findings fit into context outside of the study situation and are determined by the degree of similarity or goodness of fit between the two different contexts. So, just like it says, can we take what we found in situation A and apply it to situation B and still have it be a good fit? Dependability is, can the variability in the study findings be ascribed to the sources, right? Is it consistent? The findings would be consistent if the inquiry were replicated, which we know we can't do, but if we had somebody else do a similar study with the same subjects or with a similar context. So, is it consistent, basically, is this idea of dependability. And then confirmability is how neutral was the data collection, and did we really get the participants' voices and the researcher being as objective as possible, even with the understanding that nobody can be totally neutral or objective. So that's confirmability. And please check them out in your readings. All right, so methods to enhance trustworthiness, and we went through these in our qualitative data collection lecture. Prolonged and persistent engagement. So rather than a snapshot, we spend a long time with people, and that can really help. Time sampling. So we systematize contacts with our participants, and we sample all the different possible situations, times, and groups. So rather than, it's convenient for me to show up at 10 a.m., I'm going to do it all then. I'm going to come at 10. I'm going to come at 2. I'm going to come at 6 at night. I'm going to come before bed, right? I'm going to look at home environment. I'm going to look at work environment. I'm going to look in the community, how this person acts. So that's time sampling. Reflexivity is this idea of bracketing and identifying our own, through self-examination, our own biases and beliefs and attitudes, and then consciously set them aside so that they don't contaminate our data collection and analysis. And triangulation is using a variety of different methods of collecting and analyzing data, either different observation, interview, and documents, or using multiple researchers, going back and checking with the participants, etc., so that we're building a stronger case for the themes or conclusions that we're looking at drawing. So here is a way of enhancing trustworthiness for each of the 4 types: credibility, transferability, dependability, and confirmability. For those of you that like charts. Okay, so sources of bias in qualitative research. Well, we talked about a lot of different sources of bias in our last lecture, but on the part of the participant, they choose to agree with the researcher because they like them or they want to be friendly. Social acceptability, you say what you think people want to hear. Habituation is providing the same answers in response to similarly worded questions. So you get in a habit if the same kind of structure of a question is asked over and over with different content, you kind of get into a rhythm of answering the same. And then sponsor bias is when a person is opinionated about the sponsor of the research, and so that influences how they answer, right? So if if some giant corporation sponsored, why would they sponsor qualitative research? I don't know. But if some giant corporation, just for the sake of example, sponsored some research and the participant really hated that corporation, that might skew how they answered. So that's on the part of the participant. The researcher, confirmation bias is the most common, and it's when I think to myself, this is what I think is going on, and then I confirm it rather than really seeing all the possibilities of what might be going on and taking that in without any bias. Question order. So asking questions in a particular order can lead to particular kinds of responses and particular building of responses on each other. So we want to be careful about that. And then leading questions or wording of questions can also be a source of bias. So if we prompt the participants, even subconsciously or in tiny, tiny ways, to answer in particular ways, then that's another source of bias. Okay, we're super close to the end. Bracketing, I spoke about in the qualitative research design, but it bears mentioning again. It is a methodological device originated in phenomenology that requires deliberate putting aside of one's own beliefs about the phenomenon under investigation or what you already know about the subject prior to and throughout the investigation. Excuse me. So it's a method of just keeping yourself honest and can be very powerful in qualitative research. All right. So comparing rigor, and this is our last slide, comparing rigor in qualitative and quantitative, right? So the truth value in qualitative is credibility, internal validity in quantitative, and etc. This is a really important chart for you to understand and dig into some so that you understand across qualitative and quantitative approaches how the trustworthiness or rigor presents itself. I think that's it. All right, everyone, you've made it through another lecture. Thank you so much for your kind attention. Please jot down your questions, bring them to class. I know this is intense content, and I'm happy to talk about it and really pull it apart and give you some more examples and also help you make sense of it. All right, have a great day. Bye.